Sa TVKASYON.
Hello there! I am your teacher Kim. Welcome to another new learning experience. I'm sure you had a great time studying your previous lessons. This is Module 3 of Quarter 1, Lessons 1 to 3 in Mathematics Grade 10. In this module, the most essential learning competency is to determine the nth term of an arithmetic sequence, arithmetic mean, and the sum of the terms of a given arithmetic sequence. At the end of this video lesson, you will be able to identify the general term of an arithmetic sequence, determine the nth term of an arithmetic sequence. Also, you are expected to define arithmetic mean, find the sum of the terms of a given arithmetic sequence, and lastly, you will be able to solve problems involving arithmetic sequence. So what are you waiting for? Go grab your pen, your notebook and module, and let's get started. Previously, you were able to define and illustrate arithmetic sequence. Also, you were able to write the general term for a particular sequence. Now, let us try to look back and relate it to our discussion for today. Here's an activity that lets you apply what you have learned about illustrating arithmetic sequence. Number 1. What is the next term in the arithmetic sequence 7, 11, 15, 19? The next term would be 23. Why? Because if you notice, each term after the other increases by 4. Number 2. What is the common difference in the arithmetic sequence negative 15, negative 5, 5, 15, 25? The common difference of the given sequence is 10. Remember that we can obtain the common difference by subtracting the preceding term from its succeeding term. Number 3. What are the first 5 terms of the sequence a sub n equals 2n minus 1? The first 5 terms of the sequence would be 1, 3, 5, 7, 9. We can obtain these terms by substituting the values of n to the given general term. Number 4. What is the general term of the arithmetic sequence 5, 8, 11, 14, 17? Take note that the general term of an arithmetic sequence is written in the form a sub n equals dn plus c. Thus, we need to identify the common difference and the constant. And from the given sequence, the common difference is 3, and the constant is 2. Therefore, the general term is a sub n equals 3n plus 2. It is not that difficult, right? Well, I'm pretty sure that you're now ready for the next set of activities on arithmetic sequence. You already know that to find the next few terms in an arithmetic sequence, you need to find the common difference or the constant amount of change between numbers in the sequence. Once you know the common difference, you can use it to find those next terms. Say we have the sequence 7, 11, 15, 19, 23. What would be the next 4 terms after 23? It is 27, 31, 35, and 39. But what if you will be asked to give the value of the 50th term in the sequence? What if you will be asked to get the sum of those terms? Would you want to keep on adding the common difference to each term until you get the value of the 50th term? Would you really want to go through the terms one by one to get the sum? Sounds exhausting, right? Well then, stay tuned and learn more from this video lesson. Now that you're all set to learn more about sequence, let's start with the nth term of an arithmetic sequence. The nth term of an arithmetic sequence, denoted by a sub n, is given by a sub n equals a sub 1 plus the quantity of n minus 1 times d, where a sub 1 denotes the first term, n denotes the term position, and d denotes the common difference. It is a rule for finding a particular term in an arithmetic sequence. Take note that a sequence could either be finite or infinite. And for infinite sequence, we can generate terms as many as we want to. Thus, we denote any term in the sequence as a sub n. For example, what is the 10th term of the arithmetic sequence 4, 8, 12, 16? In order to find the 10th term of the sequence, there is this two-step guide. Step 1. Identify the values of a sub 1, d, and n. Take note that a sub 1 denotes the first term of any sequence. And from the given, we can easily read it off, and that is 4. D denotes the common difference, which is the constant amount of change between numbers in an arithmetic sequence. Looking at the given, we can say that from 4, we need to add 4 to get to 8. From 8, we need to add 4 to get to 12. And from 12, we need to add 4 to get to 16. And so on. Thus, the common difference is 4. N denotes the term position of numbers in an arithmetic sequence. And since we are looking for the value of the 10th term of the given sequence, then the value of n is 10. Step 2. Substitute the values of a sub 1, d, and n to the rule, or shall I say, the formula. Then solve. Using the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d, substitute 10 to n, 4 to a sub 1, and 4 to d. With the values being plugged, remember that in any calculations, we follow a certain order of operations called PEMDAS. So, 10 minus 1 is 9. And with this, I get to write a sub 10 equals 4 plus 9 times 4. 9 times 4 is 36, and 4 plus 36 is 40. Thus, a sub 10 is equal to 40. Therefore, the 10th term of the given sequence is 40. But how would I know if the rule is correct? Or what would I do to verify if my answer is correct? Well, I could use the same values and plug it to the rule and generate the given terms a sub 2, a sub 3, or a sub 4. Looking at these calculations, it is safe to say that the rule or the formula for the nth term of an arithmetic sequence is correct. To better understand how does this rule works in generating terms in arithmetic sequence, let's answer this together. What is the 15th term of the arithmetic sequence 3, 8, 13, 18? Remember that there is this two-step guide that we need to follow. What's the first thing that we need to do? You're right. We need to identify first the values of a sub 1, d, and n. So, what is the value of a sub 1? Very good. It is 3. Why? Because it denotes the first term of the given sequence. How about the value of d? Great! It is 5. Why? Because d denotes the common difference in which we can get from any two consecutive terms in the sequence by subtracting the previous term from its succeeding term. Say 8 minus 3 is 5, 13 minus 8 is 5, and 18 minus 13 is 5. Thus, the common difference denoted by D is equal to 5. What about the value of n? Good job! It is 15. Why? Because we are looking for the value of 15th term. Thus, the value of n is 15. What do we do next? Yes, for step 2, all we need to do is to substitute the values to the rule, or shall I say, the formula. Then, solve. Plugging the values and following the order of operations termed as PEMDAS, what do we get? We get a sub 15 equals 73. Therefore, the value of the 15th term of the arithmetic sequence 3, 8, 13, 18 is 73. Using the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d in finding a particular term in an arithmetic sequence is literally way better than going through each term one by one. Talking more about arithmetic sequence, one of the common tasks in studying its concept is actually finding the arithmetic means. And what is it all about? Arithmetic means are the terms between any two non-consecutive terms of an arithmetic sequence. For example, insert two arithmetic means between 4 and 19. Since we are to insert two terms between 4 and 19, it means that there will be 4 terms all in all. Thus, we will insert the values of a sub 2 and a sub 3 in between a sub 1 and a sub 4. To easily do this, let's go over this 5-step guide. Step 1. Let a sub 1 equals 4 and a sub 4 equals 19, while we let a sub 2 and a sub 3 be the unknown. Step 2. Get the common difference using a sub n equals a sub 1 plus the quantity of n minus 1 times d, where the nth term denoted by a sub n is the last term of the sequence a sub 4 equals 19. Step 3. Substitute the values of a sub 1 and a sub 4. That is, 19 equals 4 plus the quantity of 4 minus 1 times d, or 19 equals 4 plus 3d. Step 4. Solve for d. Using the addition property of equality, I get to write 19 minus 4 equals 3d. 19 minus 4 is 15. Then, divide both sides by 3. 15 divided by 3 is 5. Thus, the value of d is 5. Step 5. Using the value of d, we can now get the values of a sub 2 and a sub 3. For a sub 2, where a sub 1 equals 4, n equals 2, d equals 5, I get to write a sub 2 equals 4 plus the quantity of 2 minus 1 times 5. Following the order of operations termed as PEMDAS, I'll start with 2 minus 1, and that's 1. 1 times 5 is 5. So, 4 plus 5 is 9. Thus, a sub 2 is 9. For a sub 3, where a sub 1 equals 4, n equals 3, d equals 5, I get to write a sub 3 equals 4 plus the quantity of 3 minus 1 times 5. Then, following the order of operations termed as PEMDAS, I'll start with 3 minus 1, and that's 2. 2 times 5 is 10. So, 4 plus 10 is 14. Thus, a sub 3 is 14. Therefore, the two arithmetic means between 4 and 19 are 9 and 14. Is the 5-step guide useful? It's simple, isn't it? Let's have another example, but this time, we will do it together. Insert 3 arithmetic means between 11 and 35. Since we are to insert 3 terms between 11 and 35, how many terms do we have all in all? Correct! There are 5 terms. Thus, we will insert the values of a sub 2, a sub 3, and a sub 4 in between a sub 1 and a sub 5. How are we going to do this? Exactly! We have to follow the 5-step guide. For step 1, let a sub 1 equals 11 and a sub 5 equals 35, while we let a sub 2, a sub 3, and a sub 4 be the unknown. For step 2, get the common difference using a sub n equals a sub 1 plus the quantity of n minus 1 times b, where the nth term denoted by a sub n is the last term of the sequence a sub 5 equals 35. For step 3, we will substitute the values of a sub 1 and a sub 5. Doing so, we get to write 35 equals 11 plus the quantity of 5 minus 1 times b, or 35 equals 11 plus 4d. For step 4, we will solve for d. And with the use of addition property of equality, we write 35 minus 11 equals 4d. 35 minus 11 is 24. Then, divide both sides by 4. Doing so, we get 6. Thus, the value of d is 6. And for step 5, we will use the value of d to get the values of a sub 2, a sub 3, and a sub 4. For a sub 2, where a sub 1 equals 11, n equals 2, d equals 6, we get to write a sub 2 equals 11 plus the quantity of 2 minus 1 times 6. Following the order of operations termed as PEMDAS, we start with 2 minus 1, and that's 1. 1 times 6 is 6, so 11 plus 6 is 17. Thus, a sub 2 is 17. For a sub 3, we write a sub 3 equals 11 plus the quantity of 3 minus 1 times 6. Following the order of operations termed as PEMDAS, we'll start with 3 minus 1, and that's 2. 2 times 6 is 12, so 11 plus 12 is 23. Thus, a sub 3 is 23. For a sub 4, we write a sub 4 equals 11 plus the quantity of 4 minus 1 times 6. Following the order of operations termed as PEMDAS, we'll start with 4 minus 1, and that's 3. 3 times 6 is 18, so 11 plus 18 is 29. Thus, a sub 4 is 29. Therefore, the 3 arithmetic means between 11 and 35 are 17, 23, and 29. Great job, everyone! We're down to our last lesson for today. So buckle up and let's keep going. The sum of the n terms of an arithmetic sequence a sub 1, a sub 2, a sub 3 to a sub n, denoted by s sub n, is given by s sub n equals n over 2 multiplied to 2 times a sub 1 plus the quantity of n minus 1 times d, where n denotes the number of terms, a sub 1 denotes the first term, and d denotes the common difference. For example, find the sum of the 10 terms of the arithmetic sequence 3, 9, 15, 21. To easily do this, we will go through this two-step guide. Step 1. Identify the values of n, a sub 1, and d. Since we are to get the sum of the first 10 terms in the sequence, n is equal to 10. For a sub 1, we have 3, the first term of the sequence, while d is 6. Step 2. Substitute the values of n, a sub 1, and d to the formula, then solve. That is, s sub 10 equals 10 over 2 multiplied to 2 times 3 plus the quantity of 10 minus 1 times 6. Following the order of operations termed as PEMDAS, I will start with 10 minus 1, and that's 9. Then 10 divided by 2 is 5. 2 times 3 is 6. 9 times 6 is 54. 6 plus 54 is 60. 5 times 60 is 300. Therefore, the sum of the first 10 terms of the arithmetic sequence 3, 9, 15, 21 is 300. In finding the sum of the n terms in an arithmetic sequence, make sure that you know the formula and that you know how to use it well. Now, let's have another example, and we'll do it together. Find the sum of the first 30 terms of the arithmetic sequence -5, -9, -13, -17. How are we going to do this? You're right. We have to go over the two-step guide. For step 1, we need to identify the values of n, a sub 1, and d. So, what is the value of n? What about the value of a sub 1? And d? That's it. For step 2, we will substitute the values of n, a sub 1, and d, then solve. Following the order of operations termed as PEMDAS, we'll start with 30 minus 1, and that's 29. Next, 30 divided by 2 is 15. 2 times -5 is -10. And 29 times -4 is -116. Then we have -10 plus -116. That's -126. And 15 times -126 is -1890. Therefore, the sum of the first 30 terms of the arithmetic sequence -5, -9, -13, -17 is -1890. Good job, everyone! We're finally done with the discussion. I know you understood the lesson. I'm sure you did. You see, learning mathematics is not that difficult because it has its own way to make things easier and convenient for us. Before we proceed to the evaluation, remember that 1. The nth term of an arithmetic sequence denoted by a sub n is given by a sub n equals a sub 1 plus the quantity of n minus 1 times d, where a sub 1 denotes the first term, n denotes the term position, and d denotes the common difference. 2. The arithmetic means are the terms between any two non-consecutive terms of an arithmetic sequence. And 3. The sum of n terms of an arithmetic sequence denoted by s sub n is given by s sub n equals n over 2 multiplied to 2 times a sub 1 plus the quantity of n minus 1 times d, where n denotes the number of terms, a sub 1 denotes the first term, and d denotes the common difference. To practice your skill from the lesson presented, I want you to answer the following questions. You have 1 minute to answer each item. Good luck! Number 1. What is the 15th term of the arithmetic sequence -15, -12, -9, -6, -3? A. -27, B. 27, C. -57, D. 57. Time is up. The answer is letter B, 27. Remember that to answer this, you have to identify the values of A sub 1, N, and D, then substitute such values to A sub N equals A sub 1 plus the quantity of N minus 1 times B. And when you do the math, you'll get 27. Very good. Number 2. What are the two arithmetic means between 28 and 13? A. 21 and 16, B. 22 and 17, C. 23 and 18, D. 24 and 19. Time is up. The answer is 23 and 18. Remember that in finding the arithmetic means, you have to follow the 5-step guide presented earlier, in which you have to identify the common difference using the first and last terms. By that, you will be able to solve for the arithmetic means, and you'll get 23 and 18. Fantastic! Keep going. Number 3. What is the sum of the first 40 terms of the sequence 1, 3, 5, 7, 9? A. 1,300, B. 1,400, C. 1,500, D. 1,600. Time is up. The answer is letter D, 1,600. Take note that the sum of the n terms in an arithmetic sequence denoted by S sub n is given by S sub n equals n over 2 multiplied to 2 times a sub 1 plus the quantity of n minus 1 times d, in which you have to identify the values of n, a sub 1, and d. After which, you will substitute those values in the formula. And doing so, you will get 1,600. Very good! Wow! Congratulations! I am proud of the way you worked today. You have demonstrated your understanding on arithmetic sequence very well. Give yourself a hand for a job well done. When it comes to solving problems, mathematics teaches us multiple good options to choose from. However, you'd still find yourself reworking the processes over and over again because you'll make mistakes. Who doesn't, right? Likewise, in life, when you make mistakes, things will really get tough. So, you have to stay patient and resilient in taking such challenges because you will surely learn from it. And that ends our session for today. I hope you had a great time and learned a lot from this video lesson. See you on the next episode. Thank you for watching. Keep safe and enjoy the rest of the day. Sulong Edukalidad.